Independent t-tests. This is Matthew Farber. T-tests are a type of inferential statistic. It goes beyond describing sample data the way other descriptive statistics would do, such as mean, median, and mode. T-tests enable researchers to infer results from the population based on the data. Here we have a flowchart. And again, this video will cover independent sample t-tests. To go to the bottom of the chart, to reverse engineer this, we're going to look at two different groups. They're both independent, meaning that one person is not in both groups. Johnny student is not in group A and in group B. There's no pre and post test with the same population. They are two independent groups. You could say it's one group of sixth grade students in Los Angeles doing a certain type of study skill, and the same study skill is going to be done in another classroom in San Francisco, and their means are going to be compared. So there's no pre and post test, two independent groups, and we're going to look at their differences in means, that is. There are limits to using a t-test. One cannot infer that the results would happen again in a different population group. So in the example I gave before, it could be San Francisco and Los Angeles sixth grade classrooms. One would not know if the same thing would happen again in Atlanta and Miami in their classrooms in sixth grade. Another example is if men were tested and a t-test was conducted, you cannot infer that women would exhibit the same results. And of course, each group should have the same size and be independent of one another to get the best results. Hence the name independent t-test. Data cannot be nominal or ranked. Rather use interval points. Temperature is an example in which points between degrees is in an equal interval. And avoid skewed data. T-tests work best with a normal bell curve distribution. In research, you should express the type of t-test, the t-test, t-value or test value, along with the p-value or probability value, and degrees of freedom, df, to give a complete representation or story of the results. Then the null hypothesis would be accepted or rejected. For example, the null hypothesis could state that there is a difference between the means of two groups, or there is not. And then, of course, you want to look at probability because chance comes into play as well. You want to make sure that is not the reason why. And the degree of freedom is the size of population group 1 plus the size of population group 2 minus 2. In other words, you take 1 away from each group. After the experiment, both mean scores are calculated. You can visually analyze this on a histogram, like a bar graph. Viewing a chart and describing it with descriptive statistics, though, cannot lead the researcher to conclude whether the results are reliable and would happen again if the conditions were replicated. Again, inferential. A t-test then tells the researcher whether the difference between the two sets of means are in fact reliable and not due to chance or probability. The non-mathematical formula here is t equals variance or difference between groups divided by the variance or difference within the groups. The actual mathematical formula is more complicated and will be conducted by using SPSS. The mathematics is beyond the scope of this video. The results are a ratio, as we just saw in the previous slide. The higher the ratio, the more different each group is from one another. And again, if the central tendency is widespread or scattered with a high standard deviation, the number will be more difficult to ascertain. So you want a normal bell curve as best as possible. SPSS has some freedom or an ability to work with slightly skewed data, but again, you want to make sure that you have a central tendency with a normal bell curve. P-value or probability value is used to measure the amount that probability or chance between mean scores was involved. For example, If the P is greater than 0.05, which is the default setting in SPSS, you can change it. It could be zero point 0.1, it could be 0.01, but typically, oftentimes, its P is greater than 0.05, which is what we'll use in the example coming up. That means there's a 5% chance that the change from the mean of the control groups that was due to randomness. If the test was done 100 times, over 5 of the results would have randomly occurred without any intervention. Sample size can affect the significance level. A larger sample size would change the p-value, even though the t-value remains the same. Too small or too large of a sample can affect p-value. Independent sample is one type of t-test, and that will be discussed later in the example, and that was previously touched on in prior slides. Paired sample is when one group is sampled twice, and one sample, or one-way sample, is when one sample is compared to what is already known about a population. So an example of an independent sample t-test. Testing two different groups. Independent variables is something that does not or cannot change, like the grade level a student is in or blood type. This is the grouping variable in SPSS. Dependent variables are what can change, such as scores on tests or someone's pulse after an activity. This is the test value. It's entered as a scale. Each group is, as the name implies, independently tested. There is no pre and post test. Each group's result is compared, or mean is compared. For example, two groups play an educational game and then the mean of both classrooms are compared. There's no pre and post test. Levene's test is done for the homogeneity of variances. Again, this is beyond the scope of this video, how to calculate that, but it is reported in SPSS, so it is important to know and see that the Levene's test shows if there's a normal bell curve with results clustered amongst the other results, or a low standard deviation. So here are the steps. There are multiple steps to manually complete a t-test, but again, SPSS will be walked through. In a research study, urban and suburban students play an argumentation game in which claims are backed by evidence. The game, ArgueBot Academy, uses the same core mechanic as other trading card games, like Magic the Gathering or Pokemon. It is unclear if the trading card games are played more frequently in urban or suburban settings, so perhaps there's a bias or a reason why one student group grasps concepts more than the other student group. Maybe one population, maybe the urban group plays a lot of trading card games and the suburban group does not. Maybe they play more digital games. Maybe one group plays basketball more, maybe the other group doesn't. Maybe neither group does, so we don't know. Argument cards, just as some screenshots here, so there's not just text, of course. Here you can see an example. Pikachu here on the right, that's from Pokemon, and the argument cards are on the left. The ArgueBots mimic the same mechanic as trading card games where you're matching evidence to claims. Pokemon, it would be the amount of points here, or the tail whap is matched to the Pokemon. Similarly, the ArgueBot game has different types of robots. The Comparadroid or the Observatron, and you would match up evidence. Example scenario continued. After completing ArgueBot Academy on iPad, students are tested on argumentation competencies, such as the ability to match evidence to claims. Test score data gets analyzed to see if there's a difference in learning outcomes or scores based on school setting. Setting 1 is coded as urban, 2 is coded as suburban, and the test scores are out of 10 points. You would need to state the null hypothesis, which in this case would be that the means are well, for the purpose here, The null hypothesis says there's no difference between the means for the suburban group and the urban group. And the level of risk is 0.05, that's the p-value. And the degree of freedom here, you will see that the scores calculated, we have 14 scores for population of urban and 16 for suburban, minus 2 gives a degree of freedom of 28. Okay, so now we are in SPSS statistics, and we have here the two groups, which were in Excel. Simply copy and paste it in. If you go to variable view, what I did was I changed the setting here. The setting is nominal data because you are either in one population group or you are in another population group. Urban or suburban in this case, but it could be the same as having blonde hair or brown hair, being Republican or Democrat. You're only in one group. And the score is a scale from 1 to 10. So back to the data view. To analyze it, you want to compare means. This is an independent samples t-test. Setting and score. So score is your test variable, so we move it here. Setting is the grouping variable, we move it down here. And there are question marks, so you want to define them. Oops, put it back here. Define groups. Group 1 is, we'll make it 1, 2, or you can say 1 urban or suburban, but we'll just keep it here as 1 and 2. Continue, and OK. Voila, there it is. So you've got your sample size here in your group statistics. 14 for setting 1, 16 for setting 2. You can see the means, 7.64, and in suburban, 7.88 standard deviations, and the standard error. And then down here are the independent samples test. Levine's test, once again, will show you whether or not there is the homogeneity of variance, which I pronounce different each time, I'm aware. And here we will look at the significance of two-tailed, and we will see here that the significant for two-tailed distribution is 0.693, and then we've got 0.692, and I will tease this out that this will be described fully in the results section that is just under this video that you are watching. A little teaser there, that way you'll read through the results and get the understanding there. So thank you so much.